Okay, ladies and gentlemen, boys and girls, children of all ages, this is the greatest show on earth. Okay, we're now moving to finding geometric means. And again, this has got a lot of similarities to what we did in the previous chapter section when we found arithmetic means. Because like arithmetic means, a geometric mean geometric means are terms that lie between two non-consecutive numbers in a geometric sequence. And we can find these by finding the common ratio and using our geometric nth term formula, which again, an equals a1 times rn minus 1. And so here we're asked to find four geometric means, in other words, four numbers, between 0.5 and 512 in a geometric sequence. All right, so let's plug in what we know, and then we'll figure out what we got to find out. Well, we know that an is 512. All right, and that's going to equal a1, and again, I'm going to put this in parentheses, is 0.5. Now, the common ratio I do not yet know. What about n? Do I know n? Yes, I do know n. How do I know n? Well, I've got a first number, 0.5. I got a last number, 512. That's an. I got four numbers in between. 4 plus 2 is 6. And so r is 6 minus 1. R raised to the power of 6. That's a 6. Doesn't look like it. Let's see. Oh, pitiful, pitiful, pitiful. R 6 minus 1. Okay, let's go ahead and start plugging and chugging. So I got 512 equals 0.5 R to the raised to the fifth power. Now, let me talk about this for a minute as I'm grabbing for my calculator, because what's my actually next mathematical operation? I want to divide 512 by 0.5. But you see here that my common ratio, R, is going to be raised to the fifth power. And when something's raised to an odd power, if that's a positive number, then the odd root of that number is going to be a positive number. And if that was a negative number, the odd root of that is going to be a negative number, and we can just go with what we got. That's going to be different from what I'm going to show you in the next example when we're dealing with an even power, but we'll save that. So let's see, I'm going to take 512 and I'm going to divide it by 0.5, and that's going to give me 1024 equals R to the fifth power. Now, I don't ordinarily write all this stuff, all these roots, because it just annoys me, but I'm going to do it for your benefit. So I'm going to isolate the R by taking the fifth root of 1024 equals R. And okay, I'm going to take the fifth root of 1024, enter. And so the fifth root of, so R is going to equal, I'm going to squeeze it right down here at the bottom. R is equal to 4. So my common ratio is 4. Now, I'm asked to find the four terms. Well, I'm going to take 4, the common ratio, times that first number in the sequence. That's 0.4. And that's going to give me 2. In other words, A2 is equal to 2. And my common ratio again is 4. So 2 times 4, the third number in the sequence is going to be 2 times 4. That's going to be 8. And my fourth number in the sequence, and remember I got to find 4 between 0.5 and 512. 8 times 8 times 4 is 32. And, well, I might need a little help on the calculator, because 32 times 4, that fourth number between the two, is going to be 128. Boom! I have found for 4 geometric means between 0.5 and 512. I first had to use my nth term formula to solve for the common ratio r. I had to do something nasty like take a fifth root of a large number. But hey, it's pretty good. Okay, so here's another example where we're going to find the geometric means. And we're going to discover here that we're going to be taking the even root of a number. And that's going to cause us to have to do something a little bit differently as we find these geometric means. And I think I might be... No, I'm good. Okay. All right, so I'm still looking at my nth term formula. I got an equals a1 over r n minus 1. And in this case, I'm given what the a1 is, 0.25. And I'm given 64 is a5, the fifth number in the sequence. And I'm asked to find the geometric means of the three numbers between 0.25 and 64 in this geometric sequence. And like the first one, I've got to find the common ratio, but I'm going to plug and chug. So an or a5 is 64, and that equals a1, which is 0.25, and r, which I do not yet know, I'm going to solve for. Now n, what is n? Well, I've got 1, 2, 3, 4, 5 numbers in the sequence, so n is 5 minus 1. And we got 64 equals 0.25 times r to the fourth power. All right, we're going to divide both sides of the equation by 0.25. Let's see, 64 divided by 0.25 equals 256. 256 equals r to the fourth power. And like I said before, I normally don't even write all these roots. I just let the calculator do the work for me. But why do I do that? It annoys me. But I'm going to do it for you. Now, you can debate whether you annoy me or not, but that's up to you. So I'm going to take the fourth root of 256, which is going to equal r. And let's see, I'm going to find the fourth root of 256. And I get a number 4, but is 4 really my answer? Close. But remember, I'm taking the even power of a root. Now, that means that this could be either plus or minus 4. Think about this for a moment. Now, I'm going to put this, I don't want to use 4, it gives me too big of a number. Well, I couldn't use it. Let's see, positive 4 times 4 is 16. 16, that's squared, right? Then 16 times 4, which would be 4 cubed, is 64. And 64 times 4, positive 4, is 256. But what about negative 4? Well, negative 4 times negative 4 is 16. But 16 times negative 4 is negative 64. But what about negative 64 times negative 4? And this is negative 4 to the fourth power. Well, that is positive 256. And so I have two possibilities of what these geometric means may be. The first is using the common ratio as a positive number. The second is using the common ratio as if it were a negative number, because I don't really know. I just know that I've got some possibilities here because the fourth root, the even power, in this case 256, could be positive or negative 4. So I'm going to start with positive 4. Well, let's see, 4 times 0.25 or 4 times a quarter is 1. And 4 times 1 is 4. There's my number, second number in my series. And 4 times 4 is 16. And I have found at least half of my problem. The three numbers, if my common ratio is positive 4, the three geometric means between 0.25 and 64 is going to be 1, 4, and 16. However, what if 4 happens to be -4? And I don't really know. So let's see, we're going to go 0.25 times -4. Well, that's going to give me -1. And -1 times -4, well, that's going to give me +4. But 4 times -4 is going to give me -16. Now, you might recognize that there's a pattern here. The only difference between my first possibility, 1, 4, and 16, and my second possibility is -1, 4, and -16, is my odd numbers in the geometric mean in the second portion are negatives, and my even geometric means are positive. So I'll do a little bit of reversal in signs on the first and the third geometric mean from what I found when I used +4, and boom, I've got it. If you want to multiply it all out, divide it all out by hand, you're welcome to it. I'm figuring out the pattern and seeing if I can't do it an easier way. And there I am.